Hello, YouTubers of the future. In today's video, I'm going to explain, as simple as I can, the difference between speed and velocity. In everyday language, the terms speed and velocity are used as if they were the same. In physics, however, they are a little different. Speed is a scalar quantity and has only magnitude. Velocity, on the other hand, is a vector quantity and so has both magnitude and direction. Again, speed is scalar, meaning that it only has magnitude. And velocity is a vector, having not only magnitude, but also direction. We normally represent it with a little arrow. The difference is going to become more evident when we look at this very simple problem. So we have this little panda. This is the starting point. And our panda is going to travel to the north, 1 meter, to the east, 2 meters, to the south, 1 meter, and to the west, 2 meters. Okay, so we are going to see what are we going to use to determine both the speed and the velocity. So we have again that speed is a scalar. In very simple terms, speed is equals to distance traveled divided by the time. The distance in this case is going to be 1 meter plus 2 meters, that's 3, plus another meter, that is 4, and came all the way here, that is total of 6 meters. 1 plus 2 plus 1 plus 2. So in our formula, distance is going to be 6 meters. And to make this very simple, we're just going to say that it happened in 1 hour. So the speed in this simple problem is going to be 6 meters per hour, right? But let's look at velocity. Well, velocity again is a vector, so the direction is important. And when we look at velocity, we're going to find that the formula for velocity is the change in position. We're going to represent change with a triangle and position with x, divided by the change in time. So very important to analyze the change in position. If our little panda started here, right here, and ended in the same place, what is going to be the change in position? Well, the change in position is going to be 0. And divided by time, which is 1 hour, we're going to have that the velocity for our panda velocity is going to be 0 because there is no change in position in this problem. Okay, I'm just going to change a little bit the problem to better explain, and you can totally see what is the difference with this little change. Now we are going to look at this problem, which is going to be a little different. The panda is not going to end where it started. It's going to end somewhere else. So now our panda is going to start here and is going to move 1 meter to the north, 2 meters to the east, and 1 meter to the south. So this is the starting position. I cannot draw a panda here, but let's imagine this is where the panda started. Oh my God, that's very far from a panda. So this is where it started, right? So it went up 1 meter, then 2 meters to the right, then 1 meter down. So what we have in here is we're gonna calculate again what is gonna be the speed and the velocity. So remember, the speed, the formula is distance divided by time. So what is the distance? So we have 1 meter to the north, 2 meters to the east, and 1 meter south. So that's a total of 4 meters. 1 plus 2 plus 1. So let's substitute terms. It's going to be 4 meters. And let's say it's also traveled in 1 hour. So our speed is going to be 4 meters in 1 hour. So our speed is 4 meters per hour. Now let's look at the velocity. So let's see if in this case they are going to be different in magnitude. And I suspect they will. So again, velocity is going to be equals to the change in position. In math, in general, the triangle represents change divided by time. So what is the change in position in this problem? So if this is where you start, and this is where you end, well, how far is the starting point from the ending point? Well, you have it in there. It is 2 meters. So the change in position in this problem for velocity is going to be 2 meters. And the time is the same, 1 hour. I'm just being lazy. I don't want to deal with unit changes. I'm just trying to illustrate the difference between speed and velocity. So in this case, velocity equals to 2 meters per hour. So we have the same panda that started right here, that traveled to the north, then to the east, then to the south, and finished right here. But for the same movement, we're gonna have speed of 4 meters per hour and velocity of 2 meters per hour. So you need to be extremely cautious when you are presented with problems. Are they asking you for speed or are they asking you for velocity? The clue is when they ask you for a speed, everything counts. Every single part of the trip counts and you have to add them all. But if they are asking you for velocity, you just need to look at, okay, where this movement started and where it finished. How far are these 2 points apart? That is going to be your change in position. You don't care about the going north, the going to the right and down. You just care about the beginning and the end. How far apart are they? And that's going to be your change in position. So I hope this is helpful, and probably I will create another video showing a little more complex problems, showing the difference between speed and velocity.